Hi guys, so it's probably been a while since you've used scientific notation, so I'm going to give you a little reminder on this, and really the real reason why I use scientific notation. So we're going to need our notes, which is pen and paper, and we'll probably even need a calculator as well, so dig that out. We're talking about why we need scientific notation and the rules for negative and positive exponents. So we use scientific notation to simplify long numbers. One of the major reasons we also use it here in chemistry is also to figure out which numbers are significant in a calculation. So let's take this example down here. We have 280,000 times 10.0. So just like we would for our rules previously, when we multiply, we're just going to go ahead and multiply them out. So we have 8, let's see, and then 1, 2, 3, and then one more 0. So we have 2,800,000. So now we have to figure out which numbers are significant. Don't forget the rules for multiplication and division. You're going to figure out which one has the least number of sig figs and just use that many sig figs. So let's count them up. We have 1, 2, the 2 and the 8 are definitely significant, and the zeros are only significant if there's a decimal point anywhere in the number. Well, in this case, there is. So there's going to be 6 sig figs here. Let's take a look over here. 10.0. So the 1 is definitely significant. There is a decimal point somewhere in here, so these zeros are also significant. So there's 3 sig figs there. So our final answer should be 3 sig figs. Now we'd go over 1, 2, 3. Well, how do we show that this 0 is significant, but none of these other ones are significant? Alright, so we put them into scientific notation. When we are using scientific notation, go ahead and put the decimal point down. Now it's all the way at the end of the number, even though it's not there. It's kind of our imaginary one right now. So go over 1, 2, 3, 4, 5, 6 spots. You want to land between the first and the second digit. So it's 2.80, because remember that one was significant, because we need 3 sig figs, times 10 to the, what do we say, 6 spots? 1, 2, 3, 4, 5, 6. Right? So it's 2.80 times 10 to the 6th. Let's double check. We need to have 3 sig figs in our final answer, and we do. Alright, so that is our final answer. Don't forget to box it. Let's just remind you how to dealing with negative and positive exponents. So why did we make that one a positive exponent as opposed to a negative one? Well, negative exponents are going to mean that the number is less than 1. So we show that if we have 2.43 times 10 to the negative third, we go ahead and move that decimal point over 3 spots, and we want to make sure the number is less than 1. So we actually move it over 3 spots to the left. So we go over 1, 2, 3. Fill in the rest with zeros. Alright, so our final answer will be 0.00243. And of course, this one I wanted to expand it. Now, I do want to make a note. Make sure that decimal point is big and bold. And don't forget that 0 in the front. I will mark you wrong if you do not include that 0 in the front. This is why. Because sometimes people don't like to make their decimal points big and bold, and they might just make it like that. Like, oh yeah, this is the answer. Sure it is. When that may not actually really be it. They might try to fudge their way through, which is silly and mean. So put that 0 right in front so we know that that is going to be a decimal point right after it. Let's take a look at the second one. Now we want to condense this into scientific notation. We know that this number is less than 1, so we're going to move it over and have a negative exponent eventually. So we're going to go over 1, 2, 3, 4, always land between the first 2 digits. So we have 9.740. We're going to keep that 0 at the end because it was a lagging 0 with a decimal point somewhere in there. And let's see, times 10 to the negative fourth. It's negative because when expanded, that number should be less than 1, and it is. Alright, so that's our answer for this one. Positive exponents mean that the number is going to be greater than 1. So let's show here 9.74 times 10 to the fourth. We want to make this bigger than 1, so we move it over to the right, 4 spots. So 9, 7, 4, 2 zeros at the end. Oops, that's supposed to be a 9, silly. Alright, and let's make sure 1, 2, 3, 4. Perfect. So that is that answer. Now let's condense this one down here. We have 7,310. There is no decimal point, so that final 0 is not significant. So go 1, 2, 3, so 7.31. times 10 to the third. That shows that this number, by having a positive exponent, is going to be a larger number. Now, this is just kind of showing you, positive exponents, if you're going to condense it, move the decimal point, if you're going to expand it, move the decimal point to the right. For a negative number, if you're going to expand it, move the decimal point over to the left. Just kind of give you, using that 1 is kind of like a guideline or a helpful hint for you kiddos. Alright, so again, using that negative exponent if the number is smaller than 1, or a positive exponent if the number is larger than 1. Have a great day!